Welcome back, everybody. This is our third session in JEE Mains previous year questions for chapter Electromagnetic Waves of class 12th. Before this video, we have made two videos in this series and some videos for the previous chapters also. And all of those videos can be found on our YouTube channel's playlist section. And we have also started similar series for NEET previous years. So if you or your friends are preparing for NEET, then you can also watch those videos. So with this, and if you like these videos, then do press the like button, share them, and subscribe to our channel. Also, if you like to donate us something, then you can scan these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, let's start today's video. In the previous one, we covered up to question number 16, I think, or 17. Okay, yes, this was the last video up to 16th. And today we will start with the next one, or the 17th one. Let me adjust pen thickness. So here we have a magnetic field, and value of magnetic field, or magnitude of magnetic field, B node, and we have B1. So it is our field is a combination of two fields, B1 and B2. The RMS value of the force experienced by the stationary charge Q is equal to 10 raised to power minus 4 coulomb at Z is equal to 0 is close to. Now, as mentioned in the question, we have to calculate the force experience. And here, one thing that is important to notice, that here uh, we have velocity of the charge particle equals to 0. Now we know that if velocity is 0, then magnetic force, that will be Q into V cross B, that will be equal to 0. So there will be no magnetic force, and if there is no magnetic force, we have to only consider electric forces. So we have magnetic fields given, we will convert them in the electric field because this is a EM wave, so there will be electric field. And we know that for a EM wave, velocity of the wave is equal to magnitude of electric field divided by magnitude of the magnetic field. And from this, electric field is V times B, where V is the velocity of the that wave. Now, assuming that the wave is traveling in the vacuum, so V will be equal to 3 into 10 raised to power 8. So here we can find out that E node will be equal to CB node, and C is 3 into 10 raised to power 8 into B node is 3 into 10 raised to power minus 5. So this will give us 9 into 10 raised to power 3. And similarly, E1 will be equal to C times B1. So that will be 3 into 10 raised to power 8 into 2 into 10 raised to power minus 6. So that will give us 6 into 10 raised to power 2. So our combined electric field E will be written like this: 9 into 10 raised to power 3 cos of kz minus omega t plus E1, that is 6 into 10 raised to power 2 cos of kz plus omega t. And we have to also find the directions here. This magnetic field here, let me change the color. This magnetic field is in I direction, and that wave is traveling along the positive Z direction. So we know that V is equal to V is equal to E cross P. So for the first one here, wave is going along positive K direction, and we have magnetic field along I direction. So here it should be J, only then J cross I will give us, sorry, it should be negative J. I cross J is K, so J cross I is negative K, negative, negative. So here this field will be in the, we can say, negative J direction. And if we see for the E1, here wave is moving along negative k direction, so it is negative of k is equal to, and wave magnetic field is across j, so it is j. Now it will be, we can say, minus of I cross j is k, so it will be minus of I. So direction of this one will be in the negative I. So we have the electric field. Now we can calculate the force at z is equal to 0. So at z is equal to 0, our electric field will reduce to 9. This will be, we can say, here z is 0 and time will be also 0 because charge is stationary. So because no component is there regarding time, so we will consider time also 0. So this term will be reduced to cos 0, and cos 0 is 1. So what we will have, we will have 9 into 10 raised to power 3 with negative sign in the j direction, and this will be negative sign 6 into 10 raised to power 2 in the I direction. So this will be the field at t is equal to 0 and z is equal to 0. Now force will be equal to q times E, so that will be equal to 10 raised to power minus 4 into minus 9 10 raised to power 3 j minus 6 into 10 raised to power 2 of I, and this will be equal to negative sign common, and we will have 9 into 10 raised to power minus 1 of j plus 6 into 10 raised to power minus 2 of I. Now in the options we have been given magnitude, so we can say magnitude of the force will be equal to under root, this term will be 0.9, so 0.9 square, and this term will be 0.06 square. Solving this, we will get approximately 0.9 Newton. That matches with option C. So option C is the right answer for this one. Let us move ahead. A plain electromagnetic wave of frequency 50 MHz travel in free space along the positive x direction. At a particular point in space and time, electric field is given. The corresponding magnetic field at that point will be. So we have electric field 6.3 within z direction, volt per meter, and this wave is traveling in free space, so velocity of wave will be c, that will be 3 into 10 raised to power 8, and we know c is equal to E by b. So from this, b is E by c, so that will be 6.3 divided by 3 into 10 raised to power 8, so this will be 2.1 into 10 raised to power minus 8 in magnitude. And if we see, only option B satisfy our given criteria, so option B is the right answer for this question. Hopefully you understood it well. Next one, 50 watt per meter square energy density of sunlight is normally incident on the surface of a solar panel. Some part of incident energy, 25%, is reflected from the surface and rest is absorbed. The force exerted on 1 meter surface area, 1 meter square surface area, will be close to. So we know that here we have two parts. One is reflection and second one is absorption. As mentioned in the question, that we have to calculate the force, and when an electromagnetic wave is reflected from some surface, then momentum, change in momentum per unit time, that is change in momentum per unit time for a reflected surface is twice the power of incident radiation divided by the speed of light. This is for reflection. And similarly, for absorption, that delta P by delta T, change in momentum per unit time, is equal to E by C. Now here we know that 25% is reflected and rest is absorbed. So reflection is 25% and absorption is 75%. So the amount of force, the amount of change in momentum per unit time will be, it will be delta P by delta T total, that will be twice E by C into 25 by 100 plus E by C into 75 by 100. And what we can do here, we can take this will be 1 by 4, this will be 3 by 4, and we can take E by 4C common, E by 4C common, and this will be 2 and this will be 3, so this will be basically 5C, oh sorry, 5E by 4C. Now what is E? This is the total energy incident on the surface, and that is we know that energy density is 50 watt per meter square, and we have 1 meter square surface area, so E will be 50 into 1, so that will be 50 watt. So this will be 5 into 50 divided by 4 into 3 into 10 raised to power 8, and this will give us 25, this will give us 2, and this will be 125 by 6 into 10 raised to power minus 8. Now thus it can be written as approximately 21 into 10 raised to power minus 8. And from the Newton's second law, we know that force will be equal to delta P by delta T. So this term which we have calculated is equal to force. So basically force is approximately here 21 into 10 raised to power minus 8 Newton. And the nearest match here is option B. So option B is the right answer for this one. Let us move ahead. A plane electromagnetic wave travel in free space along the x direction. Electric field component of the wave along a particular point of space and time is 6 volt per meter along y direction. Corresponding magnetic field component we have to find out. So we know that electric field, oh sorry, V is equal to magnitude of electric field by magnetic field. Now wave is traveling in the free space, so V will be equal to the C, and that is 3 into 10 raised to power 8, and that should be equal to E is here 6, and B we will calculate, so B will be equal to 2 into 10 raised to power minus 8 Tesla. Now we also have to find the direction. So we know that direction wise or in vector form, V is equal to E cross B. Now here electric field is along y direction, so it is along J, and wave is traveling along the x direction, so V is across I. So here magnetic field should be along the K, because J cross K give us I. So this is along the K direction, and or this is along the positive Z direction. So if we see, the only viable option is option A. So option A is the right one for this one. Let us move ahead. Magnetic field of a EM wave is given by this relation. Associated electric field we have to find out. So to find the electric field, we know the basic relations here. That first of all, we can write that velocity of a wave is equal to magnitude of electric field by magnetic field, and direction of velocity is equal to E cross P. Now let us find out here. We can say first let us find out the velocity. Now velocity for a wave is equal to minus omega by k. Now here omega is 6 into 10 raised to power 15, so minus 6 into 10 raised to power 15 divided by k, that is 2 into 10 raised to power 7, so this gives us minus 3 into 10 raised to power 8 meter per second, and direction is z, so along k, or we have negative sign, so wave is traveling along negative z direction. So E cross B should give us negative k. Now let us move ahead. Let us use the same this relation to sort out our possible answers. As we can see here, direction of magnetic field is this. So in option A, direction of electric field is given to be the same, and we know if we take cross product of two same vectors, then that give us 0. So option A is not possible here. So only possible answers are option B, C, D, and we can see that magnitude on each of these is same. So we will not calculate the magnitude, because in all options magnitude is same. So it will be the same in means it will be the answer if we calculate it. And if we see here this component or this expression inside the cos term, it should be same for the electric field also. And in option B this term is not same, so we can say option B is also rejected. So here we have only two options possible, that is option C and D, and for which we have two directions. So what we will do, we will use V is equal to E cross B. So let us start with this one, that initially we have 2I plus j, and we take cross product with minus I plus 2j. So let do in the matrix form ijk, and here we have to take E cross B. So this is electric field, so this will come first. So this will be minus 1, and here we have plus 2, and this will be 0, and here we will have 2 1 and 0. Now if we take the cross product, this I component will be 0. Now going to the j component, this will be 2 into 2 4 and minus 1. So here we are getting j component, and we should not get j component because wave is traveling along only z direction. So this can't be an possible answer. Let us check this one. So let me change here only only electric field component I can change here. So these are the electric field components, and let us rub these also. Now I'm using I minus 2j. So this will be 1 minus 2 and 0. So here I will be again 0 minus of j, and here we will get 1 into 0 and 2 into 0 again. Or think I might have made some mistake in the previous one. Let us check this one. And plus k, this will be 1 and minus of 4. So this give us negative k direction. So yes, that is this is the right one. So option D is the right one here, and option C will be wrong. So option D is the right answer for this one. Let us move ahead. The mean intensity of radiation on the surface of the sun is about 10 into 8 watt per meter square, the RMS value of the corresponding magnetic field. So we have mean intensity of radiation. So to calculate, to use the mean intensity, we have a relation that I by C is equal to half epsilon node E square, and also equal to B square by 2 mu node. Now this E is the maximum value, and this B is also the maximum possible value that we can have. And from this we can write basically that I is equal to B square by 2 mu node into C. Now value of I is given to us, that is 10 raised to power 8 into 2 mu node, that is 4 pi into 10 raised to power minus 7 I think, and divided by C, that is 3 into 10 raised to power 8, and taking under root, this will be the value of B. Now 10 raised to power 8 get cancelled, and from this we can write that we have to take under root here. So let us use some simplification here. So we can write it like this: 8 pi into 10 raised to power minus 7 divided by 3 whole under root, and this can be further written as 80 pi by 3 into 10 raised to power minus 8 and whole under root equal to B. And from this B is equal to this 81 can be, or we can take let us take pi across approximately equal to 3. So this will get cancelled, and under root of 81 will be approximately 9. So we are just taking approximation here. So 9 into 10 raised to power minus 4. Now this is value of B, and we have to calculate B RMS. So B RMS will be equal to B by root 2. So this will be 9 into 10 raised to power minus 4 by root 2. And here we have to only find the order, and that is 10 raised to power minus 4. So option D is the right answer for this one. Let us move ahead. An EM wave of intensity 50 watt per meter square enter in a medium of refractive index without any loss. The ratio of magnetic and electric field and ratio of the magnitude of the magnetic field of the wave number of the wave before and after entering the medium respectively given by. Now, as mentioned in the question, that there is no loss without any loss. So if there is no loss means intensity is constant and speed inside the vacuum, or we can say outside that medium of refractive index n. So C will be here under root mu node 1 by under root mu node and epsilon node, and inside the medium velocity of the wave will be equal to 1 by under root k times we can write mu node times epsilon node, where k is the dielectric constant and assuming that medium is non-magnetic. So if we divide both of these, what we will get? We will get C by V is equal to under root of K, and C by V is the refractive index of the medium. So from this, N square is equal to K. This is our first relation. Now, as we already mentioned that intensity is constant and intensity is equal to half epsilon node into electric field into velocity. So in vacuum, this will be half epsilon node E square into C, and inside so this will be E node, and inside the medium this will be half epsilon node into E square times V and multiply the K, where K is the dielectric constant, because inside the medium it will be epsilon, and that will be K times epsilon. So from this we will have E node square, epsilon half and half is cancelled. So E node square by E square is equal to Vk by C. Now V by C is equal to, from this one we can write that V by C is equal to 1 by under root of K. So this can be written as K by under root of K, and this will be under root of K, and from this under root of K is equal to N. So under root of K is equal to N, and further E node by E will be equal to under root N. Now if we see that first we have to find out the ratio of magnitude of electric fields. So ratio of magnitude of electric field is root N. So that is satisfied in the option B and option C. So option A and D are cancelled, and then we can take it further, as we know that for vacuum C will be equal to E node by B node, and inside the mediums V will be equal to E by B. Now if we divide both of these, we will get C by V is equal to E node by E and multiply B node by here B. Now C by V is equal to under root K. So this will be under root K. Now E node by E, here we had it is equal to, well, let us write down it as under root N, and here we have B by B node. Now under root of K is also equal to N. So from this relation under root of K is N. So this is N is equal to under root N into B by B node, and from this B node by B will be equal to 1 by under root N. And if we match this one now, what we will have? option B get cancelled, and option C is the right answer here. Let us move ahead. So here we have a 27 milliwatt laser beam has cross-sectional area of 10 mm square. The magnitude of the maximum electric field in this electromagnetic wave is given by. So we have to find out value of maximum electric field. Now we know that intensity of a wave is equal to power by area, and that intensity is this I is also equal to half epsilon naught E square times C. So we have the power, we have the area, we know epsilon naught, we know C. So from that we can find out. So here P is 27 into 10 raised to power minus 3 divided by area, that is 10 into millimeter square. So minus 3 into minus 3, so minus 6, equal to half. Epsilon naught will be 8.85 into 10 raised to power minus 12 into E square into C, that is 3 into 10 raised to power 8. When we solve this to find out value of electric field, we will find out it to be 1.41 into 10 raised to power 3, and that can be written as 1.41 in kilowatt per meter. That is option D for us. Now let us move to the next one and the last question for today's video, that if the magnetic field of a plane electromagnetic wave is given by this relation, the maximum electric field associated with it. So we know that velocity is equal to electric field by magnetic field in magnitude, and here to find the velocity, it is already mentioned that it is moving with speed of light, that is 3 into 10 raised to power 8. So we can write 3 into 10 raised to power 8 is equal to E by B. Magnitude of B is this, that is 10 raised to power minus 4. So E is equal to 3 into 10 raised to power 4 Newton per Coulomb. That is option B for us. So option B is the right answer for this one. So hopefully whatever we have covered today will be helpful to you and understandable also. If you have any doubts or suggestions, you can put them in comment section. And if you like these videos, then do like it, share it, subscribe to our channel. And if you like to donate us something, you can scan any of these QR codes in front of your screen. With this, we will meet in next video.